Going on, it's Justin Dickmeyer from engineeringtrainingexam.com, and in this video we will review geometric sequences and series. We will begin by defining the general formula for the nth term and find some specific terms. We will then turn it around and look at how we can determine the general formula from a number of given terms. We will wrap up our review by looking at geometric series. A geometric sequence is a sequence where each consecutive term is derived from the previous term multiplied by a fixed number called the common ratio. So the sequence 1, 5, 25, 125, and so on is an example of a geometric sequence. The pattern is that we are always multiplying the previous term by 5. Not every sequence that has a pattern in multiplication is geometric. It is considered a geometric sequence only if it is being multiplied by the same number each and every time. So the general formula for a geometric sequence is this: a sub n, that's any term in the sequence, is equal to a sub 1 times r n minus 1, where a sub 1 is the first term of the sequence and r is the common ratio. So let's look at how we can determine the common ratio of a geometric sequence. Let's look at the geometric sequence a sub n is equal to 5 times 3 raised to the n. The first thing we need to do is find the first 4 terms. So a sub 1 is equal to 5 times 3 raised to the 1, which is equal to 15. A sub 2 is equal to 5 times 3 raised to the 2, which is equal to 45. A sub 3 is equal to 5 times 3 raised to the 3rd, which is equal to 135. And a sub 4 is equal to 5 times 3 raised to the 4th, which is equal to 405. Now, generally it's good to write out at least 4 terms of a sequence just to confirm that the common ratio remains the same. And from observation we can see that the common ratio is going to be 3 in this case. And we could have simply just defined that looking at our general equation, but I just wanted to play out the first 4 terms to show you how you could find the common ratio. So now let's look at a list of terms and determine what the general formula would be from that. So let's say that we have a geometric sequence 16, negative 4, 1, negative 1/4, and so on. Now we know the general formula is a sub n times a sub 1 times r n minus 1. Which means we need to define the first term and we need to define r. Now let's determine, it's obvious that the first term is going to be 16, so a sub 1 is 16. Now let's determine the common ratio. Writing out this sequence or looking at this sequence, so from 16 to negative 4 we see that the first term is divided by negative 1/4. Let me write this over here so don't run out of room. So we notice the difference between the first and the second term is that the first term is divided by negative 4. And the same goes for the second to the third term, and from the third term to the fourth term. So we see that the common ratio, r, is going to be negative 1/4. So putting this information into our general formula, a sub n is equal to 16 negative 1/4 raised to the n minus 1. So let's look at geometric series. The sum of the first n terms of a finite geometric sequence is s n is equal to a sub 1 times 1 minus r raised to the n divided by 1 minus r, where r does not equal 0. And a1 is our first term, and r is obviously our common ratio. So let's take a look at an example how we can put this to use. Say that we want to determine the sum of a finite geometric series I 0 to 20 of 3 1.1 raised to the n, or sorry, raised to the I. It doesn't matter. Right now I'm using the variable I. It could have been n, but in this case I use I. So we want to find the sum of the first 21 terms of this sequence, because we have the sequence starts at 0 and goes to 20. So 0 counts, so that's 21 terms. We want to find the sum of the first 21 terms. So a1 will be 3 times 1.1 raised to the 0, because the first term a1 is actually a0, and that is 3. And we see that each term, therefore, the common ratio is multiplied by, it's already given, r is 1.1. So plugging this into our general equation here, we find that s of 20 is equal to 3 times 1 minus 1.1 raised to the 21, because our terms, we want 21 terms, n is equal to 21, divided by 1 minus 1.1, and that's about 192. So what this is telling us is that of the geometric sequence defined by the equation 3 times 1.1 raised to the I, the first 20 terms of that sequence is equal to 192. And those are geometric series. So that's all I got for you guys today. If you guys have any questions or feedback, hop on over to engineeringtrainingexam.com and shoot me an email. I'd love to hear your feedback as well as your suggestions and any questions you may have. I'm here to help. All right? So for now, take care. We'll talk soon. Bye.